In today's video, I want us to look at the inverse functions. So before we get into inverse functions, I just want to set out a disclaimer. So I have made this series of lectures. I've broken them down into much shorter parts, and this was done on purpose so that the series of lectures then do not bore you. That's the first. All right. And secondly, so that you have a shorter video that you can replay over and over and over again. All right. Until you understand the concept very well, so well that you, without having to go back and play a long video just to get a certain part. All right. Let's get into the video. So let's start by asking ourselves, what exactly is an inverse function? Inverse function is simply a function that reverses what the original function does. So what does this really mean? So this is what it means. So if we had an original function f of x, and we given the value of x to be 2, and we run 2 into the original function, and it gives us 5 as our output. What the inverse of this function would do is reverse what we have done using the original function. So the inverse, what it would do, it would take this output and make it an input, because it's reversing what we have done. We get exactly a 2 because we are reversing what the original function has done. An important thing to note is that for an inverse of a function to be considered a function, the original function must be a one-to-one function. Right. So one may ask, so does this mean that if a function is not a one-to-one, it does not have an inverse? And the answer to that is, it does have an inverse, but the inverse of that function is not a function. In order for us to get the inverse to be a function, if the original function is not a one-to-one, we have to restrict the domain. So when you restrict the domain of the inverse, what you are doing is you are choosing certain values of x to input into your inverse function. For instance, let's say we had an inverse, we say we have an original function, f of x is equal to x squared. So the inverse of this function is not a function. So in order to get the inverse of this function to be a function, what we have to do, we have to restrict the domain. And when we restrict the domain, that's if we either choose the values of x to be x from 0 to infinity, right? So we choose x to be greater than 0. That is, we choose the values of x. For that, we would get a function that's going to pass the vertical line test. Remember how we test if a function is a one-to-one function. So this is how you do. Remember, we used the horizontal line test. If you haven't watched the video, please go back and watch it. So if we have this function over here, right, and the function over here, and our desire is to know which one is a one-to-one. So what we would do is we'd perform a horizontal line test. And the way we do that is we draw our horizontal lines cutting through the function. And if the horizontal line cuts the function only once, the function, which is the graph or the curve, just like that, so this means the function is a one-to-one. But if we draw our horizontal line like that, if the line cuts the graph or the curve more than once, that means the function is not a one-to-one, and therefore its inverse is not a function. And hear me well, I am not saying it does not have an inverse. I am saying its inverse is not a function. Yes, it does have an inverse, but that inverse is not a function. In order to turn it into a function, we have to restrict the domain. Now that we understand what an inverse of a function is, what we need to do is find a way of finding the inverse. If we are given the original function and our desire is to find the inverse of that function, what should we do? So the first thing that we need to do, let's say, for example, we are given y is equal to minus 2x plus 3. And the question says, find the inverse. What we should do is, always the first step is interchange the values of x and y. That is, Where there is x, you put your y. Where there is y, you put your x. All right, let's do that and see what happens. This becomes x is equal to minus 2y plus 3. After doing that, what we should do is write this equation in terms of x. That is, make y the subject of the formula. Let's do that and see what happens. When we make y the subject of the formula or writing the equation in terms of x, this is what we get. So this is the inverse of this function. So what you should check for now is this a function? If it is a function, you should write it in a function form. And by the function form, this is what I mean. You must write it in terms of f of x. And when we do that, we get minus x over 2 plus 3 over 2. So this is a function with a gradient of half and the y-intercept of 3 over 2. What we can do is we can look at the idea of an inverse function from a graphical point of view. And when we do that, first thing that we would realize when we look at it graphically is that the inverse of a function f of x is actually a reflection of the original function. So this is a reflection of the original function about the line y is equal to x. And by y is equal to x, this means that all the points along this line have the same value of x and the same value of y. This is what it actually means by the line y is equal to x. And another thing that we realize is that what this does is it looks at the points. For instance, this point right here is 0, 1. And the point on the inverse function is going to be 1, 0. So what the inverse does is we said it reverses what the original function has done. So what it does is if we have a point x and y, what the inverse will do is change that into yx. It will take the value of x and make it the y value, and take the y value and make it an x value in the inverse function. So basically that's the whole idea around inverses and inverse functions.